Okay, before the class start, someone asked me for the handouts for today's lecture. Today I'm going to share with you some stories. So I didn't prepare handouts. The PowerPoint or the material is not that much cell biology content. They don't contain that much content, okay? So I'm not going to give you the handout. All right, so today, that was the course introduction. Okay. And so the first topic I'm going to discuss is phenylketonuria, PKU, which is a genetic disease, metabolic disease. I'm going to tell you about how it was discovered. Okay, so if you remember this, last semester when we introduced metabolism of amino acid, okay, we discussed this story. This young lady who is the same age as you, she is a patient of phenylketonuria, but she lives pretty much a normal life, right? Except she has to limit, she has diet restriction. She cannot eat normally, but she survived, right? Okay, so that was the metabolism of amino acid phenylalanine. So this is just to remind you what happens in phenylketonuria. In biochemistry, we mentioned that phenylalanine was degraded to tyrosine, and the enzyme, phenylalanine hydroxylase, if this enzyme is defect or your body don't produce enough enzyme, phenylalanine cannot be degraded, all right? So phenylalanine will accumulate in the cells. When it's accumulated too much, it will get out of the cell, go into the blood, and then go into your urine. And also, when phenylalanine cannot convert it to tyrosine, all right? So the people because tyrosine is a non-essential amino acid. Normally, your body can generate tyrosine through phenylalanine. But in this disease, tyrosine cannot be produced normally, right? So, and again, in phenylketonuria, phenylalanine accumulates and it will turn on an alternative metabolic pathway. So the excess phenylalanine can be converted to phenylpyruvate and then to phenylacetate, phenylactate. So in PKU patient, not only phenylalanine concentration in the blood, in the urine, increase, all these three chemicals have higher concentration, right, in blood, in urine. Okay, so I just want to remind you this part. Okay, so the story begins almost 100 years ago. Today, this is 2025, all right? So around 1930s, okay, this young lady, she's Norway, I don't know how to spell it, okay? This young lady, she got married. Her husband is dental student, going to study to become a dentist, all right? And they were happily married and had a young daughter. Her daughter's name, this is her daughter, Liv. Liv, okay. So the young couple with the children with young girl okay, live a happy life. However, Liv couldn't speak until she was 3. At age 3, she still couldn't speak. Let's see if I can find a video to show you. I want to show you how找不到我要找的东西了啊，拿在手上。Just give me a second。有收音吗？没关系，没事没事，是我自己找眼镜。
哦，不要那个。
是我自己的问题。Okay, sorry。there.
Am I heavy? How heavy do you think I am?
I think.
Yeah, you do that, but then why do you stare at me when you fart?
Because I used to give my butt gas.
Yeah, but when your butt gets gas and you let that out, why don't you just say, excuse me?
Because I said, whoop. But Daddy is.
Okay, now ask me a question. Ask me a question. You gotta ask me a question. What is that? What is this? What is this? What is it? And why is that so funny? What is it? Oh my God.
Okay, I just wanted to show you normal 3-year-old girl. She can respond, have conversation with people, all right? But for Liv, she couldn't speak. Her growth is apparently delayed, okay? So the young parents was really worried. They took her to the doctors. But the doctors examined Liv, couldn't find anything wrong with her. Remember, that was in the 1930s, okay? A lot of things we didn't know. We don't know, that's before phenylketonuria was discovered, okay? Inborn error metabolism. Many metabolic diseases are not known, okay? So the doctor examined the Liv. She looks perfectly healthy, but her development, mental and physical development, is apparently delayed. So the doctor told Borgney, saying that, well, children develop at different speed. No need to worry because the examination shows she's normal, right? The doctor couldn't find anything wrong with her. So just say, well, don't worry about it. We will continue to monitor her progress, okay? And even there's some doctor assured Borgney saying that, oh, I learned to speak after 3, so don't worry. Every child has different, develop at different speed. No need to worry, okay? But again, Borgney had a second child, Dag, a younger brother. Okay, Dag, when he was born, he was perfectly normal. After a few months, after 6 months, he started to show delayed development. Okay, his symptom is worse than Liv when she was at that age. All right. So the parents got even worried. They took the children to different doctors, but still they couldn't find anything wrong. Okay, but the parents know something actually is not normal. So Okay. The second person I want to introduce is Folling. Let's see if I can use a different video.
Bone Arrow Metabolism 这个系列，我们继续介绍另外
Sorry about that. So all the doctors told them, your kids aren't just normal, because they couldn't find anything wrong through examination. All right? The examination, the techniques used in that time period. So after, but this in 1934, Dak, the younger brother, couldn't sit up by age 1. Okay, normally the toddler can learn how to crawl and start standing up, start walking around age 1, 12 months. So Dak was also development behind. Okay, this is a normal kid around 8 months, but Dak couldn't at 3.5. This photo was taken in 1934 when Dak was 3.5 years old. You can see from the picture, he cannot stand on his own. The mother has to lift him, all right? So, and through her sister, she talked to her sister. Her sister has a relative, a distant relative, who is Dr. Folling, okay? A doctor, a pediatrician. And so the mothers thought maybe we can ask Dr. Folling to take another look of these 2 children. Okay. All right. Dr. Folling. So who is Dr. Folling? He's from Norway, physician and biochemistry, okay? And he enjoyed doing research in chemistry. So after getting his MD degree from Norway, he visited United States and did research program in US. He went to Harvard University, Harvard Medical School, Mayo Clinic. You know Mayo Clinics? 美约诊所, okay? Very famous clinical institute, all right? And he also did a lot of chemistry with professors like this one. Okay, he spent different times at Harvard, Yale, Johns Hopkins, Mayo Clinics, and he learned some chemistry, did some chemistry experiment in Colorado, United States, in Lawrence Henderson's lab. Who is Lawrence Henderson? If you had chemistry before, remember this relationship? Henderson-Hasselbalch equation. Describe the weak acid dissociation, right? How to determine pKa. So this equation was developed by Henderson, and Dr. Folling did some experiment in his lab. So he's very good at chemistry. Okay, here's a photo of Folling in Henderson's lab. All right, so after all this research experience, he went back to Norway and started practicing medicine as a pediatrician. So Borgny realized that her sister is a distant relative of Dr. Folling. So she asked her sister, can you ask Dr. Folling to examine my children? All right? So, you are all future doctors. You will get a lot of requests from your relatives, from your friends, family friends. Can you take a look at my children? Can you take a look at my symptoms? What would you do? Happily accept it, or that's a lot of work, extra work. I don't want to do it in my leisure time. Right? Not very willingly, but he did say, well, bring the children, I'll examine them. However, it's the same story. They couldn't find anything wrong. He couldn't find anything wrong with the kids. All right? And so, during the conversation with Borgney mentioned that her children not only has delayed development, also she found the kids smells. There's a musty odor from the kids, all right? So that's different from other kids, from other normal kids, all right? So the Dr. Folling said, suspect, if it smells, then could be something wrong in the urine. So she asked the mother, can you bring some urine from the children to me that I can do some analysis? All right, so Borgney, in the following visit, Borgney brought Liv's urine to Folling. And he analyzed using whatever techniques is known at that time, but he didn't find anything wrong. Everything is normal. Okay. Just normal. So, but the last test he did, it's not moving. Okay, a musty odor, she noticed. But and he checked the urine. Most of the tests are normal. The last one he tried was ferric chloride. Okay, so the last test was ferric chloride test. Normally, this is to check whether there's a ketone in the urine, all right? If there's ketone, it should turn brown. However, when he add Liv's urine to the ferric chloride, it turns green. This is new. He had never seen it before. But that gives him a hint. There's something different from this child. Okay? So he asked the mother, what do you feed the children? What do you give the kids to eat? Do they eat the same as other kids? Or do you eat something different? If you eat different things, your urine, if it's not digested, if it's not degraded, it will be excreted from the urine, right? No? Yeah? For example, vitamin B, if you take vitamin B, the urine color will be more yellowish. If you eat the fruit, 火龙果, right, the urine will turn red. All right, so there's some pigment can be excreted. So Dr. Folling, the first thing came to his mind is asking the mother, what do the kids eat? Do they eat normal, or do they take other like herbal medicine, other treatment, the non-traditional alternative medicine? Okay, so Borgney says yes, of course, because We didn't know what to do. I'm facing the two retarded children every day. I have to do something. So they tried alternative medicine. So Folling told her, well, let's stop those herbal medicine for 2 weeks. And then bring the urine again to me. Okay, try to eliminate those possible causes. So after 2 weeks, she brought the urine to Folling and test the ferric chloride again. It shows greenish, right? And also, Borgney brought the urine from Dag, the young brothers. It showed up the same results. So, till this time, Folling knows there's something wrong or something different in children's urine, but he doesn't know. He didn't know exactly what it is, right? This is the first results to turn green. No, there's no reference you can find in the literature. So, and there's no diagnosis to Borgney. He still doesn't know what happens to her children. But since Folling had a lot of experience in chemistry techniques, so he asked Borgney to bring more of kids' urine so he can analyze, try to find out what kind of chemicals, what compound was in the urine that changed the color. So back and forth, Borgney collected at least 20 liters of urine to Dr. Folling. And he finally analyzed it and concluded it contains phenylpyruvate. Okay, but still, there's no knowing of the amino acid pathway, metabolic pathway. They don't know where the pyruvate coming from. Okay, at that time. So that's it. That's it. To Borgney. He didn't offer any treatment or any suggestions what to do with the children. If you were Dr. Folling, are you going to continue following the case? What can you do? What would you do? That's it. Or apparently there's something extra in the urine that's different from other normal kids. And the kids showed obvious retardation. Okay, so what's the link between these two things? Is this the reason for the retardation of children? Or, so what can you do in this situation to follow up? Any idea? Okay, so what he did was, well, even though he cannot offer an explanation or treatment to the children, but he kept thinking about this problem. So he went to the institution that take care of the mental retarded person. Okay, and to collect their urine sample. Analyze those people, those retarded person in the institute, and found many positive. Okay, so what's the connection of this substance that turning the ferric chloride test green and the children's mental retardation? What's the relationship between them? So he collected many retarded person's urine from the institution. He analyzed 430 samples and found 8 positive ones. There's 8 other people's urine had the same color change as Borgness children. All right? And also, among the 8 people, 2 of them, two pairs of siblings. Okay? Brothers, sisters from the same families. What does that tell you? What does that tell you? Yes, please.
It might be related to the genes.
Yeah, could be genetics, right? Also, Liv and Dag, they're sisters and brothers from the same family, from the same parents. Okay, so this gives Folling an idea. So, but that's it. That's all he can do. But anyway, he wrote a paper about this, what he found about the analysis results from 430 samples, and 8 of them had the same problem. Okay, so he didn't call this disease phenylketonuria. He just said the urine found phenylpyruvate. Okay, the article was not published in English because he's Norwegian. All right. Anyway, so this was the discovery of PKU in 1934. All right, so I'll show you this. This is Borgness. Her children live, circle represents females, right? Square represents male. This is a family tree. Okay, you can see the relationship between Borgness family and Folling's family. Okay, Borgness and her husband had 2 children, Liv and Dag. Both of them are PKU patients. Borgness and her husband are normal. Okay. Her sister married her husband. Her husband is in the same family, a distant family of Folling. Okay, so she is not actually related to Dr. Folling. However, due to this distant family relationship, she found Dr. Folling. And Dr. Folling, because he worked hard and he stepped further. Okay, not only continuing analyze to find out what's in the urine that may be the cause of their retardation. He also make a step further to collect urine sample from other retarded people and find the correlation of these 2 things. So the conclusion is the chemical in the urine is the cause of mental retardation. All right, so that was the discovery in 1934. And this discovery, is this a coincidence? If Borgness didn't find Folling, this will not happen, right? Is it a coincidence or it's by fate? They're determined to be discovered by him. Okay, you had enough of my talk. So let's get back to some questions on the Moodle. Where's my Moodle? Okay, in your Moodle, I have some questions for you to answer. Please spend some time, log into your Moodle and answering these questions. Okay, they're quite easy based on the story I just tell you. Who discovered phenylketonuria in what year? What unusual sign led Folling to investigate the children's condition? And what chemical did Folling identify in the urine sample? And what amino acid could not be properly metabolized in PKU patient? This is just a review of your biochemistry, right? Okay, so please take some time to do this.